Apa basic electric? What's the difference between electric field and current? The most obvious. Electric field already has a predetermined direction, right? From positive to negative. Yes, exactly. Positive to negative. Right? So in that manner, you already know that one side of this will be positive, one side will be negative, depending on your power supply. The power supply determines which direction you're going to operate the circuit. Alright? So today, you are trying to prove or trying to show the theory that electric field 1 does move from positive to negative, and remember the topic of electric field, I talked about electric potential and also electric potential energy. Those two things are different, right? So one, if I just say electric potential, it refers to the voltage, isn't it? But electric potential energy is the potential energy of the whole system, right? So if it was voltage, and now if you watch the lecture videos and in our lecture, voltage dengan distance will be affected by resistance kan. So if you want the voltage to carry the current further, you must have high voltage. Right? So that means for every distance or range, there will be different values of voltage. But you don't mention voltage because in this level we call it as potential. Right? So that's why we say equipotential. So technically, theoretically, the distance between positive and negative poles of a voltage connection will have different levels of potential, right? So since electric field moves from positive to negative, you can actually also figure, right? The further it goes away from one, it will decrease, and the closer it gets to the other side, it will increase. That means the potential technically should have, because the electric field doesn't just move like that. If it was in water or in a conductor, the electric field will spread out, right? If it was just moving in a wire, yes, you know that the vector will be just in this wire, it's just going to go one direction. Then you can mark your equipotential lines. For every range of distance, different range, you have certain voltages. But if it was in an area, okay, let's say this whole building, this whole room is a conductor, and I'm a voltage source, I'm the positive side, so positive to negative, so the vector will go out, right? So those vectors, those electric field vectors will be what? It will be omnidirectional. It should be the same, right, in every direction, right?
Yeah.
Because I'm assumed like a sphere. Because if you remember when you studied chemistry, we are assuming that everything is coming from a spherical point, right? A point. So that means you are going omnidirectional. That means 360 degrees, all directions the same. So that means, let's say this is a point. Okay, let's say this is the point where the voltage comes out. If I measure a distance of 5 cm here and I get 5 volts, if I measure another 5 cm here, I also get 5 volts. If I measure like this, I also get 5 volts. So today you're going to test this in water, right? So first of all, question, do you think water is a good or bad conductor? It is a conductor, definitely, but is it a good conductor or bad conductor? In your point of view, I know you don't study this, it's not written in the syllabus, but to your knowledge, do you think it's good or bad?
It's a bad conductor. Bad.
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 Okay. Fish say bad. Anyone say good? It's okay. There's no right or